So welcome to this video on sedimentation. What we have running now is a very simple model written in JavaScript of sedimentation in a body of reasonably still water, such as a lake or deep within the sea. We have particles falling down. They're randomly generated at the top here in some position with a color that changes through time, as in when each particle is created, it gets a color, but the color that is assigned changes with time. So we get different layers of sediment building up here. Now these could be different particle sizes. The model doesn't account for that. We're just getting different colors here. We can see the progress of time through this very simple model. Let's just quickly run that again. We need to look at some other aspects of this model. So this is, as I said, modeling sedimentation within this body of water. And each particle falls down, obviously. It goes down, it looks below it and sees if the next step below it is free and open. If it isn't, it looks to its left and to its right. See if it can move one step diagonally down left or diagonally down right. And it will keep doing that if the diagonal is free. If not, it stops. It's not a particularly good model, this. It's reasonable, it works for the purposes of this video, but we don't get any effects of pressure from above. There's no slumping. We have kind of steep angle of repose here. We'll run the model again soon with a higher resolution just to see some of these effects. So let's just switch to a higher resolution model. So let's change the resolution of this model. Here we are in model. The pixel size is actually the particle size. We'll change that to 1. We'll decrease the time step so it goes a little quicker. This mound size, we'll come back to that later. But let's go to our model here. Let's reset it. Now we can see we have much finer particles. These red ones that came down first, they're connected to this mound size, but we'll talk about that in a minute. Here we can see this snowfall, if you like, of particles falling down in our body of still water. And as we can see, they build up. They're randomly generated, as I said earlier, across the screen, and they fall down over our image here, the bottom of the sea or the lake. And we can see them building up layer by layer. And as I said, they're physically accurate, not hugely. We have a simple form of gravity pulling the particles down, but really, as I said, there's no slumping. Nothing much happens. Once the particle has come to rest, it doesn't then start moving again. It falls as far as it can and then stops. This is important because while this is sort of interesting in itself, it's a kind of a flat surface and it's staying reasonably flat. We've got these small variations, as we can see, due to the randomness of this process. Pseudo-random, it's a computer, but we'll say it's good enough for random. If we now go back and play with that mound size setting, we can see what that is all about. We'll restart this again. Now, what's happening now is we're creating two mounds. These could be bedrock pre-existing our sedimentation process, or they could be an initial trigger. We have the stream pouring into a lake initially, and then the lake deepens and the sediment then falls from a much more diffuse spread out area. But what we can see is that there is a tendency for the particles now to fill in the lower areas first. They roll off of these slopes as far as they can and fill in these lower areas. This will result in a smoothing of the topography. What started off with these two red hills here, as I said, that could be bedrock or the initial stages of the sedimentation, that then gets smoothed out by the subsequent sedimentation from this deep water environment, where we just have this general snow over the whole area of particles moving down, so that we will tend to see that our topography becomes more and more even. We no longer have these hills sticking up. Obviously, in the initial stages, they're still there. They're becoming kind of rounded. We couldn't say for definite what the initial form is. This will, generally speaking, become less and less evident, these mounds, and we will get a more even topography. Again, this model is not perfect. So where we would expect to see in a wet, loose sediment in this environment that it should slump down and fill in these holes even more, it doesn't, because my model is very, very basic. It's a very simplified model. We also have a fair bit of randomness in this, so you can on occasions just get something that doesn't do what you want it to do. In fact, this is already starting to look a little bit too pointy there for my liking. We can run this model again at the end of this initial demonstration and see if it does something differently. We're not done yet. We can just let this run to the end, and then we can talk some more about them, about what this actually represents and how we should interpret this in terms of it being a section through, like a cross-section through some sediment, and what we would expect to see walking across the surface or see on a map. So let's just let this run to the end first, and then we'll come back to it. Okay, so now the model is finished running, we can start discussing what it is we see here. We have a pre-existing topography, bedrock, or the initial stages of sedimentation. These could be eskers, perhaps, if we're talking about material being pumped out from a glacier. Don't forget this is a side view, perhaps looking or looking head on, so to speak. We're not looking at this from above. We're looking at it from the side, head on, or something along those lines. So these could, if it's head on, these could be eskers that were the material was initially pumped or deposited by an esker in a tunnel formation at the front, and then up subsequent to that. We've had a lake build up, or we're near the sea somewhere. So we've got a deep body of water then, where material is continuing to be pumped out from the ice. For example, if this is a glacial environment, we have all this sediment being pumped out into the water that is then sedimenting out on top of all this. Or this could be some other formation. As I said, whatever this is, we have an initial topography. The important thing here is that as we have sedimented this material out, layer by layer, building it up, we can see here that we get this orangey coloured layer first and this pinky one, whatever these are supposed to represent, on top of each other, layer by layer, building them up and smoothing out generally the topography. We've lost these distinct peaks here. We still see a little trace of it, this mound here. That's arrived from somewhere. There's a randomness in this model, so we're getting that kind of effect, but generally it's kind of smoothing things out and we're losing the details that we had down here. But what does that mean for us? Well, on the map, if now this was then drained of water and this was exposed land, as it is now, without any erosion, all we'd see is this one colour on the map. Looking at it from above, we just have this one colour. But what happens if we start eroding things? Well, let's just play with a little bit of erosion here. So now I'm going to start eroding the surface down. Still, all we would see is this blue, and then we're eroding away more and more material. And now, on our map, if we were to translate this into a map and look at it from above, here we would have this blue material, then it would transition over to this green, we'd have a boundary here, and then this darker green would peak up just a little bit there, and then we'd have another area of this green, and then switching back to this blue. And remember, this is the same blue as over there, and then back to this green, which turns up again here, and then moving over into this blue. Erode even more of this material away, and we start getting another pattern, different colors coming in. So as we can see, we can erode all these patterns away, and at the surface, light green, dark green, pink, dark green, light green, here again, pink, dark green. That's what we would see on our map. So these are cross sections through the material, and the map would reflect that in the surfaces above. So I would suggest thinking about that when you're working with soil maps or geological maps of any sort. This is what we can see at depth, but what's expressed on the surface is only what's visible. And depending on how much has been eroded away and what's happened to the material since it was formed, we can get these different patterns. This switching from one material to another and then back again to the same material. It's occurring twice here, it's occurring twice there, because we've eroded it away in between hand, but it's still the same layer of material there. Okay, so that's the end of this video. What I'll do is I'll let this run again, run the whole model again, and those of you who want to watch the lovely particles falling down and building another model another topography. See if it turns out any differently next time. Don't forget this is random. You can watch that. Otherwise, we're done. So let's just set that running.